Hello, everyone, and welcome to today's critical conversation. My name's Hayaatun Sillem, and I'm the CEO at the Royal Academy of Engineering and the Queen Elizabeth Prize for Engineering Foundation. And our overarching goal at the Royal Academy of Engineering is to harness the power of engineering to build a sustainable society and an inclusive economy that works for everyone. And we've been using these critical conversations to take a look at some of the engineering challenges and opportunities that are going to be crucial to addressing this goal. Today, you're joining us for the second event in our mini-series of critical conversations on conquering complexity through systems approaches. We're going to explore how systems approaches can help us to tackle capacity building globally. The evidence is clear that it's not possible to build capacity in a meaningful way through isolated fixes, and that effective capacity building requires a deeply collaborative approach. And that is where systems approaches come in. Systems approaches are a series of tools and methods that allow us to take a holistic and collaborative way of understanding challenges. They help us to see beyond isolated problems and recognize the interdependencies, the interactions, the unintended consequences that can emerge when we look at an issue in a linear way. They also allow us to look at the challenge and the possible responses to the challenge from the perspective of many different stakeholders. Promoting systems approaches has become an important part of how we deliver impact at the Academy. There is a really close relationship between engineering and systems thinking. Engineers need to be systems thinkers to be effective engineers. They're trained to visualize complexity, to design for interdependencies, and to anticipate risks. And this mindset is invaluable when navigating the challenges of an increasingly complex world. We also know that engineers need to work in close partnership with other professions and other disciplines in order to develop solutions that are inclusive, that are safe and sustainable, as well as engaging end users in designing these solutions. And these are all hallmarks of systems approaches. Over the past 5 years, Engineering X, our collaborative program, which we co-founded with Lloyd's Register Foundation, has been working with partners across quite a different range of communities, including policymakers, to ensure systems thinking principles become more embedded in real-world decision-making. And today we're going to focus in on the role of systems approaches in capacity building, focusing on education and engineering in particular. We'll explore how systems thinking can be integrated into curricula, real-world applications, and indeed industry collaborations. And we'll also look at some of the common challenges that can be faced and how they can be surmounted, as well as looking into the future and asking what that holds for systems approaches in fostering continuous learning and innovation. And I'm delighted to be joined by 3 expert panelists for this session: Dr. Rhys Morgan, Dr. Julius Butime, and Cassandra Pagan. And I'm going to ask each of you to please give a brief introduction to yourselves and your area, starting with you, Rhys. Thank you.
Thank you, Hayaatun. So I'm Rhys Morgan. I'm the Director for Education Skills at the Royal Academy of Engineering, and I'm also a board member of the Engineering X Skills for Safety programme. The Academy has been working for a number of decades now to address engineering skills challenges, both in the UK and internationally. And over recent years, we've been applying more complex systems lens to the challenges, to understand the interplay between teaching and learning, pedagogies, accountability systems, funding, and all the different facets of an education system, both from the delivery perspective, but also the government perspective. And we'll no doubt get into more of that in due course. Thank you.
Thank you, Rhys. We definitely will. I'm going to turn now to Julius. Could you please do the same?
Yes, I don't know, it's an afternoon where I am, and greetings to you all. My name is Julius Butime. I'm an electrical engineer and currently the Dean for the School of Computing and Engineering Sciences at Strathmore University in Nairobi, Kenya. I've just got into systems thinking, well, through training, but now I'm trying to look at curricula for training other engineers and also having multidisciplinary research and collaborations looking at systems and challenges within Africa. Thank you.
Thank you, Julius, and we're looking forward to hearing more about your perspective shortly. But first, we'd love to hear from you, Cassandra.
Hi, my name is Cassandra Pagan, and I'm a Senior Principal Analyst from S&P Global Market Intelligence, and I'm joining today from Amsterdam. So I'm part of the models and scenarios team for Global Insight, and my area of expertise is in index models. But I should mention that Global Insight is very much a systems thinking approach within S&P. So we're bringing together lots of different capabilities, thinking not just about trade or just about economics or just about geopolitical considerations, but bringing all of these different fields together to be able to generate new insights. So excited to talk more about that today.
Thank you so much, Cassandra. So you can see we're in excellent hands today, and we're going to look forward to taking lots of audience questions. So please do, at any point, start dropping your questions into the chat, and we will do our best to get through as many of those as possible. But first of all, I'd like to just get things started with our speakers, and I think it's worth going back to basics. So, Rhys, what is capacity building?
Thank you. So capacity building, I guess it refers to the process of strengthening local skills, knowledge, abilities, and resources of individuals, communities, organizations to improve their effectiveness and long-term sustainability. I guess it came about in the late 70s, 80s, where international development organizations shifted from providing direct aid to thinking about longer term sustainable solutions for countries in need. It's like the old adage, give a man a fish and he'll eat for a day, but teach him how to fish and you'll feed him for a lifetime. So, but if we add engineering on the front of capacity building, so we're really thinking then about strengthening the knowledge and skills of engineers and empowering them to design, innovate and maintain critical systems within their economies, such as infrastructure, energy, manufacturing and technology, and delivering them effectively and sustainably. But it really importantly considers the role of education institutions, industry, regulators, standard bodies, professional bodies, and government to sustain and support that infrastructure, the adoption of technology, and that engineering expertise.
Okay, thanks, Rhys. And whilst I've got you, I suppose when we think about education, it sometimes seems quite a sort of siloed industry, if you like. We learn by subject most of the time. And so how can we take more of a systems approach within the context of education? So we're going to delve deeper into this in a minute, but just at the top level, what would be your thoughts?
That's such a good question. I guess if we go back to primary school or elementary school, we see much greater levels of interdisciplinarity and systems approaches to education because there's just one teacher teaching all the different subjects. So they might teach thematically. Taking the Romans as an example, they'd look at Roman numerals in mathematics, Roman history, geography. In design and technology, they might look at Roman forts and so on. But then as we go through the education system, things do get increasingly specialized and more siloed. For me, I guess the way to break that down is through greater kind of team-based and project-based learning approaches that also develop additional skills in individuals as well. These are kind of pedagogies and teaching and learning approaches that explore beyond just a single subject and a single solution. But it does open up lots of questions around things like assessment and curriculum and accountability and measuring the performance of individuals and lots of other issues. So it's not actually that trivial.
Well, I think that's a perfect point to bring in Julius. So Julius, how in your world are you going about teaching systems to your students?
Thank you, Hayaatun. I'll just take you briefly through what approaches we are using looking at systems thinking. And in many ways, we've been applying this without calling it systems thinking, in a way. What I would like to point out is that at the university, what we're really doing and would say is, one is the people getting to the university are coming from very diverse backgrounds, and you realize that so now the first thing is see how do they get to the same level and then now begin to teach, because you have varied backgrounds coming into the university and you have to build the body of knowledge. One thing we've done, and this has really worked well for us, is to look at the community engagement, because we're looking at students going back to the communities after their past year of training to then go and identify challenges within their communities. And this brings back students who have a different perspective to the realities around them. Why is this important? It's because they are going to be applying solutions that then will be impacting on the society and people and touching people's lives. And be it an engineer, be it an accountant, be it anything, they are looking at society and they have to deal with the realities within the society. So one way that we've tried to teach them is through this community engagement, which has really, so every student of ours does 225 hours in the community yearly, and it's graded. And so it gives them a different perspective when they look at now solutions for people they're actually trying to deal, and even the projects they will look and choose are looked at from that angle. The cultural context also matters very much. And when we are looking at different fields, we are within a global setting and within our regional setting in Africa, looking at the region as well, and also globally. All the influences come in, and so you realize that one solution in one place might work and might not really hold in another place. So opening the students' minds to these realities helps as you start to teach them and helping them to apply their knowledge to the different settings they're going to be working in. Also, the international exposure helps in a way because then you get to look at things from a different perspective and with different people in the room. So that's how we're going about it in trying to teach the students and passing on the skills. Thank you.
That's so interesting, Julius. Thank you. And I'm hopefully going to hear some of the examples during the course of the discussion that have emerged from that sort of community engagement. But I'm interested in this question of, do you actually integrate systems approaches into your curriculum itself?
Yes, very true. And that's part of how we build a curriculum. We don't just sit down as academics and say, okay, this looks interesting. Let's put these knowledge areas together. The process requires that you go down to all the stakeholders, ask them how this will actually impact on them. There are very iterations on how you then look at the curriculum document, look at the outcomes. And now we are actually dealing more with outcome-based education. And this is increasingly happening in Kenya, where the whole curricula has been changed to then looking from the grassroots to look at what kind of citizen do we want to now have at the end of this process. And so that's a detailed process. And now we have the first group of students coming into the universities in about 5 years. And we have to be ready for that cohort that has been trained with competence-based kind of outlooks to looking at subject areas. And so the university is also looking and saying, how do we then prepare for those learners? And of course, outcome-based education is one way to look at it, where we say we want a citizen who will go out to maybe be hands-on, patriotic, looking at different kind of aspects, challenges within the society. So those are things that go back and we feed back into what we are trying to do in building the curriculum. And so systems approaches, yes, will definitely be very handy as we look at what exactly do we want to solve, what are the societal issues that we're coming up with that we need to actually be addressing. And of course, when you look at Africa, it's education, health, agriculture, all this industrialization, power. So all these different areas will now have to be, how do we then train the professionals that will go out to address those particular challenges? Thank you.
Thank you very much, Julius. And I love the idea of asking ourselves, what kind of citizen do we want to emerge from our education process? Cassandra, I'd like to turn to you now and ask about some of the common challenges that people encounter when they're trying to implement systems approaches in the context of capacity building. Can you tell us a bit more about what these look like and how we can overcome them?
Yeah, that's a great question, Hayaatun. And I think, when we're thinking about systems approaches, by definition, there's a lot of moving parts, right? So making sure that all of those moving parts are actually going in the same direction and are headed towards a shared goal is a challenge that we see everywhere, and especially in building engineering capacity. So I'm very much coming at this from a research and data perspective, right? So my relationship here with all of my esteemed colleagues on the panel, I'm not an engineer, but I've been able to work closely with the Royal Academy of Engineering over the last couple of years to think about how we could take data and build out a systems approach to try to identify, where our challenges to building capacity. So we were thinking about all those different moving parts and how we could figure out a way to measure them and understand them in a new way. And what we found, right, when we were going through the process of this research was that the alignment between the stakeholders and defining who is part of what stakeholder group and the distinct roles that everyone has to play in building capacity, it's very complex, right? Like we're talking about systems, and in no way is any one system the same, and in no place is the situation ever the same. So at a really macro level, we wanted to start thinking about the different stakeholder groups that we could kind of build some commonalities with, right? Independent of context, and really at the core is professional engineers, right? In this discussion. But we also, as my colleagues here have mentioned, are thinking about the industries where they're working, right? And the different interests and positions that the industries are taking and the direction that they might be moving and how that might be distinct perhaps from the institutional perspective. So the way that policy shifts are having impacts, in very real ways towards engineering capacity. And the role that institutions should be playing in kind of driving safe and responsible engineering activities, but that doesn't always happen, right? All of these pieces have to move together. So I think, talking broadly about common challenges, it's actually making a system work the way a system is designed to work. And I think, given the audience here, that probably resonates really well. But, we can't assume that all interests are identical, and these positions are certainly not static, right? So at any given moment, we can take a perspective and say, okay, well, things are lining up here. We've got this partnership working very well between this group of, professional engineers and building, a better pipeline with academia and, working, with folks like Julius and Reese to, design curricula and make sure that there are opportunities to develop the skills that engineers need to be able to build more capacity. But at the same time, government plays a really big role in that, and providing funding for research is an essential part of that ecosystem, right? So as we're thinking about systems approaches, it's always about the dynamism in the system and making sure that the alignment isn't just happening in one moment, but that alignment continues, right? There's a challenge of continuity when we're thinking about systems approaches. These things are never just stuck in one place. And I think really there's a lot of dynamism that we need to account for. And this is where, me coming from the world of modeling is very interested, right? And how do we think about, how do we quantify that? How do we put numbers around that so we can maybe start to take shape about where, things are stronger, maybe where things, there's opportunities to grow and, be able to identify in more maybe concrete ways, the ways we can actually strengthen the systems and move towards improved alignment.
Great. So I think, Kathy, this is a moment to dive a bit deeper into the Global Engineering Capability Review. So can you tell us what it is and why it's relevant to our discussion about systems approaches?
Absolutely. So I've, obviously kind of hinted a little bit at this. I'm very excited about this collaboration. And when we think about partnership and think about systems, this is why someone from S&P Global is, having a conversation like this. I had the pleasure of working on the Global Engineering Capability Review, which is a forthcoming piece of research that was completed in collaboration with Engineering X Skills for Safety program and S&P Global Market Intelligence. So this piece of research is quite expansive. So this is why I'm talking in really big macro terms. But what we tried to do through this piece of work is to design a new framework for understanding engineering capability and capacity. So the framework is absolutely based on a systems perspective. And we were trying to think about, okay, we have a lot of measurements that exist around, safety outcomes, and there are different, measurements that already existed out there to make sure, okay, so we know where things maybe there's, risk of harm or where things perhaps are not going right. But what about what goes into that system? How do we know that a system is actually headed in the right direction, or where maybe there's opportunities to strengthen a system? So this new framework that we designed was really meant with that in mind. And we wanted to think about the inputs and the resources into the system, right? How do we build at a country level? How do we build out a framework for understanding where that capacity is strongest and maybe where it could be improved? And we wanted to think really closely with the Academy about how we could turn this into a useful tool and speak to the different stakeholders that we see as like the core drivers of engineering capacity. So my role in this was to actually build out the quantitative model for measuring engineering capacity. So this is why, I'm a data geek at heart. Again, not an engineer, but I love maths. And so we really wanted to think about how we could design a diagnostic tool that could speak in a much more colloquial way to the system. And this was really one of the main goals of the work that we did. So the work, like I mentioned, is global in scope. The index itself, the Engineering Capacity Index, covers 115 geographies. And we've kind of broken the model out in a way that speaks to 3 core stakeholder groups. The first is engineering professionals, the next is governments and institutions, and the third is the engineering industries that are, essential to creating this full ecosystem. We also, underneath that, decided to, design out 10 capacity areas that we identified through a lot of collaboration with the Royal Academy about, okay, so what does capacity look like when we're talking about engineers, and how is that different than capacity of government, and how is that different in capacity in the engineering industry, right? So each one of these stakeholders has a unique role to play in creating a strong system. And so we kind of went through a process of designing an index where we could kind of attribute in some way the different capacities to the key stakeholders that are really driving that capacity at the country level. So very excited about this research. There's going to be a lot to dig into, and I don't want to give away too much. But broadly speaking, we did find that the partnerships are really important, and governance are essential bottlenecks that are need to be kind of unlocked. So that's why I'm really excited to be here today and try to kind of overcome some of those challenges that we identified through the research. So keep an eye out for the report when it goes live.
Thank you so much, Cassandra. And yes, we're looking forward to sharing both the data and the diagnostic tool that you're talking about when we publish the Global Engineering Capability Review in the not too distant future. I'm really looking forward to getting stuck into the audience questions. But first of all, Rhys, let me turn to you. You've been very involved with the review as well. Is there anything you'd like to share at this stage? And is there anything you'd like to add to what you were talking about earlier in terms of how we embed systems approaches in the way we build capacity in education?
Yeah, thank you. Within the Engineering X program, we've been funding a whole range of different projects and programs in emerging economies and developing countries across the globe, driven by our aim to improve safety in engineering and apply systems approaches to capacity challenges. So, for example, we work with engineers, academics, entrepreneurs to run training programs in things like construction, civil engineering, to drive kind of culture change around safety and understanding of risks and safe practices. But it's not just working with individuals. We bring in professional bodies within the countries, government agencies, and industry, so that there's a whole ecosystem engaged in that training and improving safety. And even in the UK, there are really great examples, like organisations like Engineers Without Borders, with whom we at the Academy work very closely. We're working across UK universities to apply engineering systems thinking to final year student projects with big, broad challenges like climate change, water security, and environmental sustainability in engineering design projects. So there's lots of really good examples of how we can embed and how we can think about embedding systems thinking approaches into engineering education and in that kind of workforce training as well.
Thank you, Rhys. Now, I think I'm going to start fielding some of the audience questions. So Julius, I think there's definitely one here for you. I don't know if it's correctly pronounced. Sorry if it's not. Atieno asks, how do you ensure that systems approaches are enhanced at community level in educational engagement?
Okay, I'll just speak to that a bit. Yeah, so of course we are getting students from communities, and I think in the past it was very, I wouldn't say you'd want to use the word systemic a lot, but looking at the history of education in Africa, and you had the missionaries coming in and looking at getting students and training these. What worked really well was to get the students out of the communities into a setting where they could then now pass on new skills, and then having done that, send them back to the communities. And so that's now where you have the boarding school kind of setup where, okay, you get all these different students from their communities, give them one set of rules to follow throughout 3 months, and then push them back to the society. And so you'll find that slowly some things are passed on to the societies. And they might have been the first people to go to school. So if my generation of parents, my parents' generation, in their families, they had one out of many siblings going to school. Now, later, you have many of them getting to school. So we're now in like the fourth generation of people going through school, and we still have parts of our communities that where students coming are the first from their community to come into school in the school setting and have gone all the way up to a university. Now, the idea is for them to have the same mindset of, look, I am from a community, and all I do and what I will try to, as I advance, I have to bring up others. And so that, in a way, having that mindset, not that they necessarily have to carry that burden, but in the way they carry out things and go ahead with their lives, is that their decisions will impact on the ability of others to then now access education and look at and improve the welfare of others that really they're looking out for. So this is something that you might say with the system approach, you're looking not at the short-term impact, but you're looking at the longer-term impact of an intervention within a curricula that says, okay, why shouldn't the student be aware of what's going on in their communities? Because their awareness helps them when they become leaders or go into positions of influence to then make decisions that feed back into the communities where they're coming from and communities at large. I hope I responded to that one in a way. Thank you.
Thank you, Julius. And would you like to share an example of the sorts of community-based work that your students have done that you think might show us systems thinking in real-world settings?
Okay, so what we have is a weekend program for students. We call it Macheo, and that is so Macheo is where our students at the university will mentor secondary students within the slums. Like Kibra is one of our neighborhood slums in Nairobi and the biggest, and then you have others really. But the idea is get these students from disadvantaged communities and mentor them in like STEM areas and increase their chances of accessing higher education. And that's in the national exam. So through this, we've impacted on over 500 students to given them access to joining university. And now some of them are graduating from universities and are able to go back and impact on their communities. Why is this? Because we realize that the students realize that they are privileged to be in a university setting, but not everyone can actually get to the university by virtue of where they are. And so one of the things that you'll find is that given there is no mentors to actually kind of encourage you on your journey through education, you end up like, okay, I think this bar, you set the bars very low. And so that means you create a cycle of where you will not now say if people haven't gone through higher education, not that higher education is the magic bullet, but you see, it tends to be that when you access higher education, then your chances of getting certain type of employment improve. And with that, you're able to help and also do more things in society. So that is what now creates a ripple effect within the community where those students are coming from. So when the students are able to do that, then they're able to now directly see how they're touching other people's lives.
Thank you, Julius. That's very motivating to hear. I'm going to turn to Reese again because we've got some questions coming in, I think are probably in your neck of the woods. So got Freddie asking about how we can make opportunities for students to build their confidence in working with complex systems. So do you want to kick off with that one, and then we might go on to some of the other ones as well?
Yes, it's a great question, Freddie. I think it's down to us as educators to rethink what an engineering education means. And in fact, the Academy is currently running a big policy research project called Engineers 2030, which is asking those quite challenging questions. So often I think we give a problem to students and then we ask them to solve it. We might think of this as the kind of convergent stage of the engineering design process. Get stuck into the maths and see if the bridge is strong enough to stay up to carry the load. But we rarely give students the opportunity to question, did we need the bridge in the first place? We might think of this as the divergent thinking bit of engineering that is kind of lacking a lot of the time in engineering education, I think. So giving students the opportunity to reframe the problem, consider the impacts of the solution. What is the impact of building that bridge on the communities either side of the bridge? What's the knock-on effect of transport, of sustainable, of the environmental sustainability? So, there are ways that we can get students to think differently within their engineering education. But I do come back to the challenge of balancing kind of the siloed approach, which we talked about right at the beginning of this webinar, developing that specialist knowledge, ensuring that our civil engineers can do the calculations to make sure the bridge stands up, our electronics engineers, chemical engineers, they have that depth of knowledge, and balancing that with the ability to apply that knowledge to multidisciplinary systems challenges. Really good challenge.
Yeah, absolutely. So I'm going to stay with you, Reese, and then I'm going to offer it up to Cassandra as well. Got a question from Polly about how we're seeing capacity building evolving in industries with fast-paced changes, and particularly around technological development. So obviously, it's impossible to talk about anything without being aware of the extraordinary pace of innovation in areas like AI. So any comments on this one, Reese?
Yeah, our viewers are really putting the difficult questions in today, aren't they? That is a challenge. I mean, we're struggling to keep up with the pace of change of technology in the UK education system and in our industries, and I've no doubt it's replicated in other industrialized economies. I think, despite perhaps what we're seeing in politics of a tendency for increased kind of nationalist protectionism and isolationism, I think we're going to see in engineering and technology greater sharing internationally of good practice, of ways of developing skills between professional bodies, between industries, and other kind of skills organizations. And we're also going to see, a transformation because of these technologies, seeing AI play a role in driving upskilling within the workforce. And I think what we'll really see there, really interesting, think about this in a systems way, is, these are going to be non-linear effects to how we keep up with the pace of change. I think we're going to see a change in the nature of learning and qualifications. I expect we'll see an increase in kind of short duration micro qualifications that they may have a shelf life of a few years, maybe even a few months before new technologies come around and new qualifications have to be developed. So, I think we're going to see quite significant changes over the next decade. And I expect all of this to be delivered through mobile devices, which are ubiquitous across the globe.
Reese, you covered a lot there. I'm going to ask Cassandra if she'd like to comment off the back of this. What do you see at the sort of the system level, and what's the data telling us about this, Cassandra?
Sure, and I think this is where the data is particularly powerful, right? Is helping us kind of navigate how do we how do we monitor change, right? I think that's really the role that data has to play, is for us to say, okay, so we know where we are today, but how do we know how we are evolving, and what is evolving, and where is evolving, and where we maybe, need to focus more attention. So, I think that, I work in an industry that's very fast paced. So I certainly feel the need for a capacity to constantly change. I never do the same project twice. So it's always about learning new skills in terms of, thinking about creative and innovative ways to apply what we already have, and saying, all right, well, the way we used to think about economics is, it doesn't work, right, in the way that we, maybe have traditionally seen things. So how do we actually put those insights together with other parts of, how we see the world, right? So this is very much the case where I see this, every day. We're thinking about it in the modeling world. How do we bring together data that don't actually talk to each other, right? And so I actually feel like my job is very much being that translator between, types of data that don't actually have anything to do with each other, but really actually help us build a more complete picture, right? So I think that what we will see, right, and this is true of anytime we have fast change, is we'll see, some stakeholders will take this and run with it, right? And I think academia, has an important role to play here. And this is, one of the key stakeholder, one of the key capacities that we measure within the index is, how the strength of academia within a given geography. In designing the right curricula and making sure the skills are present, but at the same time we'll see perhaps more constrained thinking from an institutional perspective, right? We're seeing trends in the world where some things are just hurtling at light speed, right? So the development of technologies, but how we actually can regulate or monitor or enforce regulations around technologies is a much slower pace of change, right? Our governmental systems are not necessarily designed to be super responsive to rapid change. So I imagine, again, that the utility of data is really to help us understand where the divergences are, how big those gaps get, and how can we, accelerate where we need to accelerate, right? And I think building out trajectories is an important piece of the puzzle, right? And I think that, the advanced technologies are one of many industries that will experience this. So I imagine we'll have a lot more data to look at in the future.
Thank you, Cassandra. And I'll just stick with you quickly to allow us to spend a minute on Alice's question, which is, I think, around what does the data and evidence say around which types of systems-based interventions have been successful in the context of capacity building. Are you able to give us any responses to that, Cassie, please?
Yes. So, where we see places that, have been particularly successful, right, are really where the strength of partnerships. So thinking, really breaking down those silos, right? Not just thinking about, the role that a government has to play, an enforcement agency, standards bodies, operating in isolation. It's really where the collaboration comes into place, right? So the strength of partnerships is really what unlocks and drives a lot of improvement in capacity building. Another one of the key trends that we found in the data were really actually about enforcement. So we put things on paper, we say a lot of things, we say we want these policies to move forward, but at the end of the day, the incentives and the positions are hard to align, right, in a system. So industries have their own, they're thinking about it in a different way, right? They have their own stakeholders. Industries are thinking about, generating revenue oftentimes, and not necessarily focusing on kind of some of these broader goals. So, it's where the enforcement capacity of governments is effective, quite frankly, that has another really important effect, right? So it's what we found in the data is truly where the silos break. The countries and the geographies where the silos break are where the systems are the strongest, right? So when we can actually look towards the other, the other parts, the other stakeholder groups, and not say, you're not one of us, so I'm not going to worry about this. That's not effective. It's really about thinking how we solve problems together. How do we understand each other's positions? How do we understand what are the incentives at play, and how we can kind of get to a place where we all agree to move in the same direction, right? So that was really what the data showed us in a broad way across all regions.
Thank you, Cass. I really like that. Where the silos break, the systems are strongest. And you touched on partnerships there, so I think I have to bring Julius in at this point and just ask you to share a bit more about the role that you see partnerships playing, partnerships between industry and academia and government in helping get those systems approaches integrated into the way that we train our future citizens.
Thank you very much. Just to highlight the fact that there's a big shift towards challenge-driven education, outcome-based education, and many of the things that we're looking at from a systems perspective are that now I, as a lecturer, don't have to think through all the problems I have to prepare for my students. I have to say, okay, let's see who are the stakeholders involved in this. Does the government have any issues they want to address? And this can be put through like some challenges through their industry is a big player in looking at things they would want to solve. And we're calling this applied research, or looking at challenges coming from industry. And so now the conversation pushes academia to actually go out and sit in fora where we can actually get to hear what's happening on the ground and what's really happening, and avoid the ivory tower mentality where we are know-it-alls and then the others are supposed to just listen to us. And so that doesn't hold anymore. And increasingly with the amount of information out there, we now see the need to actually get the students working on real solutions that are going to be taken up in the next, immediately. And this is something that builds the need for the partnerships that we have to then build, both with the local governments and also looking at the town councils and then the local industry within the countries and also without, because we are also increasingly in a global environment, and many projects are like multinational and looking at all the kind of funding for different activities within development projects. So you find that you have a myriad of stakeholders to look at and now navigate. So the work of the student becomes a lot more difficult when you're preparing them for such an environment. You have to now see, are they actually going to be able to deal with the different scenarios or different realities they have to face as they look at, say, I have the technology, I have the knowledge, but I can't get funding for my work. So does that mean that I don't solve the problem that I have identified within the place? Because many of the things we deal with are not to do with technology, are dealing with financing for the solutions that you actually have to then implement. And that is now a different ball game for engineering, because now you're like, okay, now I have to now add on the hat of fundraiser or build a business plan, which takes them out of their comfort zone, but is a place they need to learn how to play. And so, because that's what now will make sure that you get the solutions for the communities that you're trying to actually help.
Thank you. So that's really a cultural shift we're going through, and we're sort of resonating with Cassandra's earlier point about the importance of alignment of the elements within our ecosystem. Reese, I'm sure you've got thoughts on this. You're welcome to add a few in, but I'm going to try and also push us to get through a few of the questions that are still stacked up. So maybe we're going to try and have a few shorter answers. So Peter's asking about a general value function for measuring successful outcomes, partly so that we can get better at transferring our knowledge and our learning from one context to another. What do you think?
Are you giving me all the hard questions today? Peter, crumbs.
Don't worry, I can help as well if you want.
Oh, Julius is offering you a get out of jail card here. Come on, Julius, you go in first while we
You go, yeah.
Okay, I think what we need to ensure from a technical perspective is that if we are talking engineering, and it's a standard globally, and that is now that they have the same set of skills across from country to country. And now that's where the standardization bodies come in. We have the Washington Accord looking at international accreditation of programs and standards across for training for engineers, engineering technicians, and technologists. Now, that is one minimum without which we cannot now begin to collaborate. So we have to agree that an engineer in one place is the same, has the same knowledge as an engineer in another place. Now, I think that's the global function that we're looking at in terms of what's the base on which we're going to build. Now, going from that, the context in which you find the engineers can vary and is varying, and the cultural elements that come in, those now are the issues we begin to navigate. But I think the one we cannot really rule out is that the foundations have to really be taken care of. Thank you.
So thank you, Julius. That's given you some more time to think, Reese. So
Yeah, thank
go
you.
on then.
Well, I
Our
mean,
expectations are high now.
I mean, I'd be amazed if we can find a universal value function, because the systems that we're thinking about are so inherently diverse and context dependent. And just building on Julius's point, it's not just about engineering, but there are political, economic, psychological, sociological dimensions to these kind of challenges as well, that where engineering takes place in the world. I guess there are certain things that we can think about, things like resilience, efficiency, adaptability of the system, and you can perhaps look at how we can compare systems using those kind of metrics. But also, when you think about things like the interdependencies of elements within a system, you have different feedback loops and things like that, and you have non-linearities coming in again. So trying to say, yes, we can compare one system to another is going to be very difficult. I think I need to go on this future of a systems engineering program to see if I can learn some more.
All right, we'll park that at this point. I think it is one to reflect on further, and I think we can feed it into our thinking at the Academy as well. But I'm going to turn to Tim's question now, and this is really going back to Cassandra, some of the points you raised about how important it is that new technologies are adopted in a way that is safe, and is safe in terms of limitation of human harm and delivery of benefit for people. How far do we go in our global engineering capability review to understand where those needs are most urgent, or indeed maybe where they're being well dealt with?
That's a great question. So, when we were designing, the models that would help us be able to answer these kinds of questions, right? We started at this from a capacity, thinking about what are the inputs, right? But that was only half of the picture. What we needed to also have is we needed to understand, okay, well, where are those inputs actually having impact, right? So we actually ended up going through an exercise to build a second index. And that was really focused on safety and quality infrastructure, and really, how do we know where, the engineering activities are safe and effective, right? And that's really, the exam question at the end of the day is we wanted to know where, measure the capacity and be able to break apart where, what are the elements of capacity, where could we, improve, where are opportunities to get better. But it didn't matter if we couldn't also see the outcome. So we put the two pieces together to be able to answer this question. And we said, all right, where in the world is there high capacity and high outcomes? Great. Okay, that's expected. But what about the places where those things aren't aligning, right? So as part of our analysis, we came up with a way of identifying geographies based on, kind of a matrix, basically thinking about, in where these things are diverging. So again, we expect to see, where a lot of input is happening, high outcomes, where there's less, relatively less input happening, less capacity, less safety, less quality infrastructure, right? The lessons to be learned are in the places where, the inputs are actually maybe more effective and maybe where the systems are working best, right? So where the inputs and then the outcomes are actually, higher than expected. But it's the places where, you're putting a lot of energy into the system, you're putting the inputs in, but you're still not seeing the return on those investments, right? Like if you are putting in the skills training, if you're investing, energy in developing the kinds of standards practices that need to be, contextualized and localized, right? This is very important to making sure that, the outcomes are actually, effective, right? The way we're thinking about governance, that the enforcement mechanisms are there, that, industry is being held accountable. But those things aren't aligning, right? And so we kind of said, well, that's a really good indication for us that there's a pretty high risk of harm. So we wanted to take it from a data perspective and say, where could we figure out where these things are working and identify best practices. But we definitely did want to be able to answer that question through the data. So again, 115 geographies have been included in that. We're not necessarily interested in putting a rank. That's not the whole purpose of this. This is really about having a conversation about where are we doing this well and where can we get better.
So I think, Cassandra, what everyone is thinking, but what's the answer? And of course, we're going to be releasing that data when we publish the report. And I wonder if one of my colleagues would be able to drop into the chat for those watching on LinkedIn Live what the expected publication date is, because I think you probably whetted everyone's appetite. I'm going to try and squeeze in one more question before we do a rounding off, and I'm going to give you heads up that the question I'm going to give you all the chance to contribute to just before the end of the session is, what would you really like to see us doing better in order to foster that culture of continuous learning and innovation through better deployment of systems approaches in the way we do capacity building? So that's going to come right at the end. What's your big ask? But before then, I'd like to just touch on Richard's question, which is how we make sure that we build systems literacy, but an openness to systems approaches, I think, amongst clients, because it's all very well to be training people in engineering and in our education systems to be able to deploy systems thinking. But if actually the people they then have to work with and convince to accept solutions are not open to that, we're not going to get the outcomes we're looking for. So does anyone want to come in on this one? Reese, I'll start with you.
Yeah, thank you. It's another great question. I think the answer for me here is in collaborative design. I recall a civil engineering organization telling me a story about the construction sector. Construction is a very linear process. The client goes to the architect draws up the design, goes to the structural engineer who says you can't make that, so they have to make some modifications, go back to the client for approval. Then it goes down the chain to the building services engineer who says, yeah, but now I'm going to have to put all ducting over your beautiful architected designed building. And so they're not thinking through all the different elements. You get to the fire engineer who says, well, I need to put fire break walls in here, or I have to put in, fire kind of sprinkler systems and things like that. So by bringing everyone together at the start in a collaborative process and working together, these are the ways that the client can see how systems and the different interplay of all the different aspects within the system kind of play out. And they've been doing this in manufacturing for years. Collaborative concurrent design has been going on in automotive sector since the 1980s. So it's not a new phenomenon, but it is for different sectors. And I think it's about looking across different parts of engineering, different sectors, and saying, come on, let's just apply this here a bit more. So there is an education to be done for clients, for sure.
Thank you, Reese. And I'm just going to quickly add in a concrete example of how we try and support this at the Academy, which is to run policy fellowships for senior civil servants, for mid-career and senior civil servants, to help them understand systems thinking approaches and their relevance to whatever policy challenge it is they're working on. And by supporting them in that process and helping them access external expertise, it means that they become a stronger client in the future for the sort of systems advice. So that's just one specific example, and I'm sure colleagues can drop a link in the chat to our policy fellowship programme if you'd like to know more about that. We're nearly out of time, so I'm going to give you all the chance to have a moment of dreaming about what you would like to see in the future. in terms of embedding some of the approaches that we've been discussing in the reality of how we do capacity building in a global context. So I'll start with you, Julius. What would be your one big wish?
Okay, this is one thing, and I'll just take us a bit back to our younger years. And just imagine Julius at 20 and all the ideals that you have to change the world as you start engineering. And the things I wanted to do with engineering really were like really transform the country and do many things. As you get out of engineering school, then you start to realize that, okay, now it's not as easy as I thought. So now for the young people, the idea is how do we keep that zeal to actually change the places they're in and keep them motivated without really bringing down the harsh realities, which is what at many times will now kind of dull that kind of initiative. And now with systems thinking, I would imagine this is one thing that we actually have to see, that we keep them motivated and incentivized to really look at keeping the dream alive to actually now transform the places they are in and the countries they're working in, the places they're going to work in, the industry they'll go to. And many times you want them also now to acquire different skills. And that's now, other than the technical, they need a lot more like getting to rally the teams together to actually get buy-in to support what they're trying to build and the solutions they're trying to provide. And this is not something that, so it has to be really put within, it can be taught, but also it has to be lived. And so that's what I would really say that is one thing that we could add to this particular conversation. Thank you.
Well, who could argue with keeping the dream alive? Come on, Cassandra, over to you.
Oh my God, Julius, how am I going to follow that? Well, okay, I will maybe piggyback a little bit off of what Reese said, and I love, what you said about, collaborative design. And this is a lot of what I think about doing in my own work. And I think, if I could ask anything, it would be, for all of us, and we're all experts in our own ways, to embrace being a good listener. I think it's something that, especially when you work in a high-skilled environment, you find very few people who are good at that. And I think that what we could do to be better at, building stronger systems and learning from each other and understanding where we can break down the silos is actually just getting better at listening.
Fantastic, Cassandra. 2 ears, 1 mouth. Reese, over to you.
Thank you. Yeah, a great answer, Cassandra. So all babies are born as engineers. Everyone is a proto-engineer. When as children, we build things and we knock them down and we explore and we're creative and we're curious. And I think I'd really love the education system to nurture those engineering skills right throughout childhood. And we talk about engineering habits of mind in the academy. So those divergent skills that I mentioned, systems thinking, problem finding, and then and creative problem solving, adapting ideas from one context to another, all of those things. Wouldn't it be great if our education system developed those right through children's education from preschool right up to university, regardless of which subject you did? Compulsory engineering habits of mind for all.
Well, we're all proto-engineers. It's not a phrase I hear every day of my life, but what a lovely optimistic note from all three of you to end on. So a huge thank you to our panelists for such an interesting and stimulating discussion. There was a lot to get through because you posed us some brilliant questions, audience. So thank you so much for staying with us and for posing your very insightful questions. I always like it when the panel have to work hard. And I hope that you found it helpful for shedding some light on why systems approaches can be so valuable, why they're so relevant to trying to make progress in this complex, unstable, and definitely challenging world that we live in. and also a few tips on how to use them in practice. If this conversation has sparked your interest or you have any further comments about today's event, please do respond to the survey that's going to be posted in the chat and will be emailed to you as well following the event, because your feedback helps us to shape and improve our future events and to make sure that we're being as useful and relevant as possible. Stay tuned for future critical conversations on our LinkedIn page. We're going to have the final event in this mini-series on Wednesday, 23rd of April, focusing on governance of complex systems, and there should be a registration link appearing soon if it hasn't already. And you can also catch up on all previous critical conversations via the links in the chat. So thank you again for joining us. Thank you to our panel, and look forward to seeing you soon. Thank you.